All right, let's just jump right in. You do it, I do it, we all do it probably 100 times a day without even thinking about it. You type a web address into your browser, you hit enter, and boom, this whole universe of information just pops up on your screen. But have you ever actually stopped to wonder how that really works? Like, what is happening in that split second? Well, today we're going to pull back the curtain on what feels like magic, but is actually some seriously cool technology. Yeah, that's the big question, right? You type something, you press a button. It seems so simple, but what's happening behind the scenes? It's like this incredibly complex, high-speed dance of technology. It's just wild. So that's what we're going to do. We're going to trace that entire journey, right from your keyboard, literally across the entire world, and all the way back to your screen. And the best way to wrap our heads around all this is to follow the life of just one single request. Let's pretend it's a little messenger. We're going to see how your simple command to, say, visit a website gets translated, chopped up into tiny little pieces, and then sent on this absolutely lightning-fast trip across a global network. Okay, so first things first. Before our little messenger can go anywhere, it needs an address, right? I mean, you can't just send a letter to your friend's house. You need the street and number. It's the exact same thing for your browser. It can't just send a request out into the void hoping to find a website. It needs to know the precise numerical location of the computer, the server, where that website actually lives. And that is exactly where something called the Domain Name System, or DNS, comes into play. Honestly, the best way to think about it is like a giant global phone book for the entire internet. See, we humans are good with names, right? But computers, they only really understand numbers. DNS is that amazing system that does the lookup for us. It takes the name you typed and finds the correct number. So look at this. When you type in a name, something friendly like howstuffworks.com, your computer has no idea what that is. It just doesn't speak that language. What it needs is the IP address. That's the string of numbers you see there. So you can think of DNS as this totally invisible, super fast translator that makes the entire web usable for us humans. But here's where it gets really cool. It's not just like looking in one big phone book. It's actually a whole process. Your request kind of goes on a little treasure hunt, hopping from one computer to another in this big hierarchy. It starts by asking a main root server, which is like the master directory. That server says, oh, you need a .com? Go talk to that guy. Then that server points it to an even more specific one until finally it finds the server that has the exact IP address you've been looking for. Okay, great. So now we have the address. Our messenger knows exactly where it's going. But now, how do we actually send the message? We can't just, mail the entire web page in one giant box. The internet has a way cleverer and more efficient way of handling this. And this house-moving analogy just nails it. The old-fashioned way, called circuit switching, would be like booking an entire highway just for yourself to move your house in one piece. I mean, can you imagine? Totally inefficient, right? It just blocks everything up. Instead, the internet uses what's called packet switching. And this is genius. It's like taking your house apart brick by brick, mailing each brick separately, and then just reassembling the whole thing when it gets to the destination. The craziest part? The bricks don't even have to take the same route. It's super flexible, super efficient, and it means everyone can share the highway at the same time. So what's the rule book for all this chaos? It's a set of protocols called TCP/IP. You can think of it as the internet's master control system. If we stick with our house analogy, TCP is the construction foreman. It's the one that carefully breaks the house into number of bricks, we call them packets, and keeps track of them. Then, IP is the postal service. It's the part that slaps the correct address on each and every one of those bricks to make sure they all get sent to the right place. And that is the digital postal address we're talking about. Every single one of those little packets gets tagged with an IP address. It's a unique number that basically acts like a zip code and street address all in one. It tells all the traffic cops on the network exactly where this one tiny piece of your data needs to go, out of literally billions and billions of possible destinations. Okay, so our little data bricks are all packaged up and they're addressed. Now for the actual physical journey. And trust me, this is where things get really mind-blowing. Because this isn't all happening in some abstract, fluffy cloud. No way. This is all happening on real, physical hardware that spans the entire globe. So this journey takes place on a massive physical network. First, you've got routers, which are basically the traffic cops of the internet, directing all the packets. Then, those packets pass through these huge hubs called Internet Exchange Points. Think of them like major airport hubs, where all the different internet networks connect with each other. And from there, They dive into this incredible spiderweb of massive undersea fiber optic cables that literally connect all the continents. And just to give you a sense of the incredible speed we're talking about, I love this quote from a Reddit user. It really puts it into perspective. It takes a week to sail across the Atlantic, right? But light can travel around the entire Earth 7 times in a single second. And that's the speed we're dealing with here. We're not talking about planes or boats. We're talking about data moving at pretty much the speed of light. And it's not just the speed, it's the sheer volume. The capacity of this network is just staggering. A single one of these modern undersea cables can handle 9 terabytes of data every second. Now, what does that even mean? Well, that's like streaming thousands and thousands of HD movies, not per hour, not per minute, but every single second. It's just an insane amount of data. So, our little packets have crossed entire oceans in the blink of an eye. They've been guided by all those routers, and now they've finally reached their destination. But what happens when they get there? What does the server do? And just as importantly, how does the website you asked for get all the way back to you? All right, first, we need to get 2 key terms straight: client and server. It's really simple. Your browser is the client. Think of it like you in a restaurant. You're the one asking for something. The server is that powerful computer on the other end of the line. Its whole job is to listen for those requests and, well, serve up the files that you asked for. Pretty straightforward, right? So the server basically catches all those individual bricks of data that you sent. Step 1, it reassembles them to figure out what you actually asked for. Step 2, it processes your request. It goes and finds the web page you wanted. Step 3, it sends back a quick message, a status code, kind of like saying 200 okay, I got it. And then finally, step 4, it takes the actual web page content, all the text, the images, everything, and it breaks that down into a whole new set of packets for the return trip back to you. And that's the home stretch. Those new packets, the ones carrying the website, they race all the way back across the globe. They arrive at your computer, and your browser is there waiting to catch them all. It uses those TCP instructions to put all the pieces back together in the exact right order, and just like that, it renders the complete web page right there on your screen. And the amazing part? That whole round trip happened in less time than it takes to blink. Okay, let's just zoom out for a second. We've gone through this incredible technical journey from click to screen. It's amazing. But what's the big idea? What's the fundamental principle that makes this whole globe-spanning cooperative system even possible in the first place? Well, here's the secret sauce. It's not some locked-down proprietary technology owned by one company. As this quote from European Digital Rights puts it so well, the real power of the internet comes from its fundamental openness and flexibility. It was built from the ground up on open rules, open protocols like TCP/IP that anyone could use and anyone could build on top of. And that, right there, became the engine for all the innovation we've seen. So, when you boil it all down, this whole incredible system that connects all of us, it relies on cooperation. It relies on openness. And that, well, that leaves us with a really important question to think about for the future, doesn't it? In a world that's full of competing interests and companies and governments, what's it going to take to protect that core principle? How do we make sure the internet stays that open, collaborative platform for everyone?